Hi everyone, this is Jeff from Stratford Helms, and this is a recap of today's Math Roundtable Word Problems 2.0, including the algebra lesson we did after the PowerPoint. If you got a chance to call in today for the Zoom call, I really appreciate it. You were a great group and you did a great job today, and it was really my pleasure to host the call. If you didn't get a chance to call in today, this will serve as a nice overview of everything that we went over. And also, whether you called in or didn't, I'm going to have a chance to spend more time and go into more detail during this YouTube video than I did today on the call. So it should be great for everybody. Now, this is going to be building on Amy's Math Roundtable, which was about word problems from 1 week ago. But we're going to kind of focus on a specific aspect of word problems, and I think it should be interesting for everyone. So let's take a look. Okay, let's just move this down here, out of the way, and there we go. All right, so reviewing Amy's Math Roundtable from a week ago, we have Amy's steps to solving word problems. Now, these are really good steps. There's 4 of them, and these are really good to kind of, review, certainly, before we jump in today. So, step 1, highlight or underline the important information. You see a number, definitely want to key in on that for sure, focus on that. There's going to be relevant and irrelevant information given to you in your problems, whether you're working on a GED, a HiSET, or a TASC, or you're just working a grad point for your learning, for practice. So part of solving word problems is to know what's important. The second step, determining which operations are needed, is once you know what's important, it's knowing what to do with that important stuff. Okay, so when you say operations, operations mean add, subtract, multiply, divide. Okay, so next step is once we know those things, we're going to write out the problem using numbers and operations. Makes sense? And then the fourth step is to solve it. Okay, so today we're going to be focusing on one aspect of this, which is determining which operations are needed. And we're going to do that using something that I call math talk. Okay, what's math talk? Good question. So math talk is something that I use with my students very frequently as a way to refer to the keyword or keywords in a word problem that tell you the operation or operations that you're going to do in order to set that word problem up as an algebraic equation. Okay, so breaking that down a little bit further, that's kind of a mouthful, but what's that mean? Well, when I say math talk, what I mean is there are going to be words that you're going to see, and they're going to signify certain things. Okay, you're going to see a word and it's going to mean you're going to add. You're going to see a word and it means you're going to put a variable there. You're going to see a word, it's going to mean equals. There's an equal sign. And what those words let you do is they let you decode the word problem and write it out as an algebraic equation, meaning something like x equals. Okay, so an equation is something with an equal sign, and an algebraic equation would have a variable, basically. So if we can set a problem up as an algebraic equation, we can solve it algebraically, meaning using algebra, which quite frequently can be a very straightforward and consistent and therefore easy way to solve a math problem. So let's take a look. Setting up a problem algebraically. This is kind of just what we just talked about, okay? So just a little overview. So to set up a problem algebraically means to make it into an algebraic equation so that it's, and this is very important, in some cases, easier to solve. Now, sometimes you're going to see the answer to these problems right away. Okay, there'll be a word problem, and it'll be something like, what's 2 plus 2? Well, 2 plus 2 is 4. No reason to set that up algebraically, okay? But for more complicated problems, there is, a real need to set it up as an algebraic equation for consistency and ease of solving. And we're going to see that here, certainly. But some of our examples will be a little bit easy just to make it easier to learn. And we can certainly build on that foundation. Okay, so here are some math talk keywords, okay? And these are going to be broken down by type of operation. So first we have addition. Okay, now addition is the operation, meaning to add, okay, meaning a plus sign, okay? If you see the words sum, sum of, etc., or total, you know you're going to add, okay? So if you see what is the sum of 2 and 3, well, that means 2 plus 3, okay? Next up, we have subtraction, difference or decrease, okay? Same thing. So say we said, what's the difference between 6 and 8. Okay, well, 6 minus 8, -2. Okay, so the difference would be -2 in that case. Multiplication. These come up a lot. Okay, so especially one of them. Okay, so you'll see product, you'll see of, the word of by itself. Now that means not sum of, but just of by itself. Each and double, triple, etc. Now, of comes up a lot. So if you see something that says, what is 1/2 of 10? It just means 1/2 times 10. Okay, so it's that of by itself is showing you the operation will be multiplication. You put a multiplication sign in. 1/2 of 10 is 1/2 times 10. Okay, which is 5. Next is division. So quotient, ratio, per, share, or divide equally. Those are all the keywords that would cue us into division happening in a problem. Okay, so if we see, what is the ratio of bananas to apples? Okay, and there are 6 bananas and 3 apples. We know it's 6:3, or 6/3 as a fraction, which would kind of mean division, which would simplify down to 2/1 or 2:1. Okay, so the ratio would be 2:1. And, I know without writing these down or seeing them, these examples can be hard to follow, and that's okay. We're going to definitely write down plenty later, but just kind of hitting the high points here. Okay, next up is equals. Now this is a really straightforward one, comes up all the time. So I've been saying for a lot of these, I've been saying, what is the sum of, what is the difference, what is the, what is 1/2 of 10? Well, is a big part of that. So equals is. So is equals is. So meaning if you see a word problem and the word problem includes the word is, meaning what is 1/2 of 10? So what equals 1/2 times 10? So we solve the is and the of. And variable, okay? A variable is an x, a y, an n, etc. It's a letter that stands in for basically a question mark. We don't know, okay? We don't know what that is yet. So it's going to be some number, but we haven't figured it out yet, so we use a variable. And the words what or how much are what are the keywords that would let us know we're working with a variable. So if we go back to one of our examples that we've been using, what is 1/2 of 10? Well, what tells us we have a variable. So x, y, n. So let's pick one. Let's pick y. Okay, so y is, okay, well, that means equals 1/2 of, we see of by itself in the multiplication, so it's 1/2 times 10. So y equals 1/2 times 10. Wow, okay. So y equals 1/2 times 10, y equals 5. Well, great, y equals 5. So we don't, y isn't a question mark anymore, y is 5. So that's great. Okay, let's move on. So example 1. What is the sum of 15 and 3? Okay, so let's break this one down. So we can figure out the answer to 18 just in our heads, because this is a pretty straightforward example, because 15 plus 3 is 18. And we're going to use this example, even though it's easy, to get used to setting things up algebraically. So we're going to translate it into math talk. What's the sum of 15 and 3? So what is becomes x equals. What becomes the variable? Is becomes the equal sign. We take our numbers, we bring them into the algebraic equation untouched. Numbers, we always focus on numbers, just like Amy's example from last week. Numbers are really important information. We always focus on numbers. They come in unchanged, okay? And we see sums, that means addition. So what is the sum of 15 and 3? X equals 15 plus 3. Then we just solve that. X equals 15 plus 3. X equals 18. Great. Okay, example 2. What is 20% of 360? Okay, slightly more complicated. So we see, real quick, we're going to cue in on those numbers. 20% and 360. Okay, now we see some words. What is and of? Let's break it down. So what, that's our variable. In this case, y, okay? Is equals, okay, so y equals, bring our numbers up untouched, 20% of 360 becomes 20% times 360 because that's of by itself, which means multiplication. So what is 20% of 360 becomes y equals 20% times 360. In order to solve it, we can write it out like this. Put it straight into the calculator, for example. We can turn 20% into a decimal if we'd like and do it by hand. Either way, we're good. And we come up with 0.2 times 360, which is 72. So y equals 72. Okay, example 3. Bob has 6 pieces of gum. Susan has 2 pieces of gum and Kim has 4 pieces of gum. What percent of the group's gum is Bob's? Okay, so this word problem, while the operations we're using aren't particularly complicated, we're getting a little bit more into looking at necessary and unnecessary information. So we don't have to really worry about what they have. They all have the same thing, which is pieces of gum. And the question's asking us, what they're asking us is what percent of the group's gum is Bob's. Okay, so we can assume it's the total number of pieces of gum in the group. And we see a lot of mention of pieces of gum. So Bob has pieces of gum, Susan has pieces of gum, Kim has pieces of gum. Okay, so basically we can break it down as Bob has 6, Susan has 2, Kim has 4. Okay, so what percent of the group's gum is Bob's? Okay, well, how much does the group have? Okay, we have to figure that out first. Well, Bob has 6, Susan has 2, Kim has 4. So 6 plus 2 is 8, plus 4 is 12. Okay, so let's break this one down. What percent of the group's gum is Bob's? Okay, what? That's a variable. In this case, n. Okay, we used n. We could use x or y or whatever. We used n. So n percent. We bring percent up as a percent sign. Okay. Of. It's of by itself. It's not sum of. It's of. So that's multiplication. So n percent times the group's gum. Now we talked about that. So the group's gum means the total number of pieces of gum in the group, which is 12. Is Bob's. Is means equals. Okay, so equals Bob's. Bob has 6 pieces equals 6. So n percent times 12 equals 6. That's our algebraic equation. N percent times 12 equals 6. Now in algebra, what do? To undo multiplication, we divide. To undo addition, we subtract, and vice versa. So we're going to use the inverse. We're going to use the opposite operation. So n percent times 12 equals 6. We're going to divide by 12 on both sides. Okay, so if we divide n percent times 12, if we divide that by 12, if I give somebody $5 and then I take that $5 back, well, nothing really happened. Okay, so if they had $20 to start with, I give them 5, I take 5 back, they still have $20. If they have $0 to start with, I give them 5, I take 5 back, they have $0. So in this case, if we're multiplying by 12 and dividing by 12, nothing happens. So that multiplication goes away because of the division. They cancel each other out, and we're just left with n percent on one side of the equation. On the other side, though, we have 6 divided by 12. So n percent equals 6 divided by 12. 6 divided by 12 equals 1/2. 1/2 equals 50%. So our n percent is 50%. So there we go. So what percent of the group's gum is Bob's? 50%. It means he has half of it. Does that make sense? Yeah, if he has 6 pieces, the group has 12 total, then Bob has 50%. Okay, great job, everyone. Thanks for joining. Okay, so that's the end of our PowerPoint, but let's jump into some of that algebra we were working on. So let's dismiss our PowerPoint here. Escape, and we'll minimize that. Great. Okay, so let's take a look at how our screen's set up. On our right, we have our Math Talk keywords. Okay, addition, subtraction, multiplication, division, variable, and equals. In the middle, we have a paint window where I can write things like hi. Okay. And on the left-hand side, we have the TI-30 XS Multiview, which is our official calculator for the GED, HiSET, and TASC. This is TI SmartView software, and I'll put a link to that software in the video description. If you download it, if you have a laptop or desktop computer, it will let you have for 90 days free the TI-30 XS Multiview on your computer just like this, and which is pretty cool. Okay, so we'll have the ability to use the calculator or not as we see fit. So let's work on some problems here. So let's start with addition. Okay, so if we look over here at our Math Talk keywords, okay, we see addition, okay, sum of, etc., and total. And let's start with that. Okay, so what do you say we write out a problem? So let's take a look here. Let's, you know what? Let's go ahead and put in some text. Okay, so here's our problem. So let's go with what is the sum of 7 and 23. Okay, there we go. It's a good question. That's a good question. All right, so let's take a look here. Okay, so what is the sum of 7 and 23? So first, let's look at our important wording and especially our numbers. So first numbers, 7, bam, 23, bam. Actually, there we go. Do that a little clearer. 7 and 23. Okay, let's take a look at this. Boom, boom. Very important, okay? Now, let's take a look at our operations, okay, for our math talk. So, do we know what is? Yes, we do, okay? What means a variable, right? Look right down there. Yep, variable, x, y, or n. We can just pick one. What do we like, okay? I like x for this problem, okay? So, x, okay. Next is, well, what does is mean? Is means equals, okay? So let's take a look at that. We're going to put an equal sign there, okay? Now next we see the, well, that doesn't really tell us much, but sum does, S-U-M. So sum of, or etc. That means addition, okay? And we get back to our numbers again, 7 and 23. So we're sum of, in this case, it's sum of 7 and 23. So what is x equals the sum of addition 7 and 23? So 7 plus 23. Okay, so x equals 7 plus 23. And 7 plus 23 is 30. We can take a look on our calculator. 7 plus 23. Enter for equals 30. Perfect. X equals 30. All right, great job. Okay, let's do a subtraction problem, okay? So that means we're over here now, okay, with difference or decrease, okay? So let's go back to text, and let's write a little problem in here. So what do you think? Let's see. Well, how about, here we go. How much is the difference between 20 and 11? Question mark. Great. Now let's take a look here. Okay, perfect. So, again, numbers first, right? 20 and 11, always, okay? Always numbers first. Now, once we pull the numbers out, now we're going to look at our words to see what Math Talk keywords we can use, okay? So, first word I see is how, second word's much. So, I see how much. Well, what do we have over here? Oh, variable, right? What or how much is our variable? Well, we used x last time. Let's try y, okay? So, here we go. So, how much, we're going to underline that, and we know that's y. Is, we know what is, okay? We look down here, right? Equals is, okay? We underline is, okay? That means equals, equal sign, very good, okay? The difference, okay, difference. Now that's a new one, okay? It's over here in subtraction, check that out. Difference or decrease, okay? So, difference, we know we're subtracting, okay? And we're back to focusing on these numbers again, 20 and 11, okay? So, in the order that they're written, always, okay? 20 and 11 with a subtraction sign in between. So 20 minus 11. Y equals 20 minus 11. So on our calculator, we clear it out. 20 minus 11, and we get 9. Very good. Okay, so Y equals 9. Great job. Okay, let's keep going. So here we have multiplication, okay? Let's work on a multiplication problem, okay? Let's go to a clean piece of scrap here. Okay, and we'll go back to text and we'll write out a nice multiplication problem. Okay, so let's get a little bit harder. So the product of 0.5 and 12 is how much? Okay, let's try that. So here we go. Okay, back to brush. Perfect. Okay, So this one's written in a little bit different order, and it also concerns multiplication. So we see right away, we see our numbers, obviously. We always focus on those numbers, okay, 0.5 and 12. Now, once we see those numbers, then we can take a look at our operations, our Math Talk keywords. So let's go over to our Math Talk keywords. Look at multiplication. Here we go. Product of each double, triple. Okay, so we see the word product, okay? We see of, but it's not by itself. Product of, well, you know, it's just like sum or sum of, okay? If of's not by itself, it doesn't stand alone, but product sure does. So product means multiply, okay? So is equals, okay? So let's put our multiplication sign. We can either use a regular multiplication sign, or we can use a dot. I like using a dot because it's a heck of a lot less confusing, especially if we have x as a variable. Okay, so let's use our dot as our multiplication sign. Okay, great. And it's a pretty bad looking dot, but we'll go with it. Okay, so is for equals. Okay, and how much? Now, what's that mean? Yep, variable. Okay, and let's use n this time. Okay, for our variable. So okay, how much? It's variable and it equals n. So the product of 0.5 and 12. Okay, so we have our multiplication sign here. That's going to be our dot. So we have 0.5 and 12. Okay, so 0.5 times 12 equals n. Let's put that in our calculator over here. So 0.5 times 12, enter, 6. Great. So 0.5 times 12 equals n. 6 equals n. All right, great job. Okay, so our last operation is division. Okay, so let's take a look at one of those problems. So quotient, ratio, per, share, divide equally. Okay, so let's take a look at you know, let's make it a little bit interesting here. Let's go to a clean piece of paper. Okay, and for this problem, I'm going to refer you back to a video I made before called cross multiplication, and you will see that on our YouTube channel along with this video. So take a look for that, and that'll be really good because it's what I always say for cross multiplication is if you know 3 things but you don't know a 4th. So let's do one of those problems here, and let's make it a miles per hour or a miles per gallon problem because we do see those a lot on in grad point and on our tests. So how about miles per hour? Okay, so man's name. Let's see. All right, Paul. Let's go with that. Okay, so Paul drove 300 miles in 6 hours. How fast was he going? Okay. Now, what's going to happen here? Well, we're going to have to interpret this a little bit using our basic knowledge, our basic skills that we bring to the table. Okay, so all of us, you know, come from different places in life, but all of us, you know, have life experience and skills. You know, we've driven, we've ridden on buses, we've you know, been in trains, planes in some cases. So let's take a look at what we know. Okay, so what we know first of all is Paul drove 300 miles in 6 hours. Okay, how fast was he going? Well, how fast was he going? That in and of itself, not too clear. Let's make a little addition here, okay? What if we say how fast was he going in miles per hour? Okay, I think that'll be a little bit better. There we go. That's better. Okay, so like I said, we all bring something here to the table. So we have our 300 and our 6. So let's focus on those. Okay, so now, like I said, we know 3 things we don't know a 4th. We'll get to that in a minute. But first of all, let's focus on what we're, you know, working with, which is our Math Talk keywords. So the fact that Paul drove, I don't really see any keywords there. Miles and hours are important, but again, they're related to the numbers 306. how fast was he going in miles per hour? Well, we have to kind of use our experience to understand that how fast and how much are really the same thing. So that's going to be our x. Okay. Now, x miles per hour, right? X miles per hour. Well, what does per mean? Well, per means division, okay? We can see that right there, okay? So, miles per hour. How many hours? 1 hour, okay? So, x miles in 1 hour, okay? So, this is going to get pretty interesting here. So, we know 3 things. We know 300 miles in 6 hours, and we know 1 hour. We don't know how many miles in 1 hour. So we know 1, 2, 3 things, but we don't know number 4. Okay, so let's figure that out. Now, how are we going to solve this one? Well, we're going to use our Math Talk keywords, but like I said, we're going to make this one a little bit harder. So if you jump over, like I said, to that cross multiplication video, this will be a lot clearer. But we're going to use cross multiplication to solve this problem. So we're going to use our Math Talk keywords and cross multiplication to solve a problem. So we're going to, over here, we're going to do miles over hours. Now, we can also do hours over miles. It doesn't matter as long as we keep it consistent. And I'm going to solve it both ways just so you can see what I mean. Okay, so miles over hours. Well, I have 300 miles in 6 hours. Okay, and down here, that would be 6 hours to go 300 miles. Okay. Now, when you start seeing things like unit rate and stuff like that, which not everybody's at yet in grad point, I'm sure, but when you do see that, the unit always assumes the unit, meaning 1. So when you see per hour, it means per 1 hour, okay? That's where we got this 1 from, okay? So they're the 3 things we know, 1, 2, 3, but we don't know a 4th. That's why we have an x, okay? So x miles in 1 hour. Okay, 1 hour to go x miles. Now, when we cross multiply and divide, when we use cross multiplication, same thing. What we're going to do here is what we're doing is we're setting up 2 equivalent fractions. Okay. Now, we're going to look in an x pattern. Okay, an x pattern meaning like this. Okay, so if we look in an x pattern, what's across from each other? 301 are across from each other here. Okay, which means to solve this one, we're going to do 300 times 1. Okay, so this is our multiplication. And we're going to divide by 6 because, again, going in an x pattern, 6 is across from the variable. So if numbers across from number, we multiply. If numbers across a variable, we divide. Again, this might seem a little confusing, but if you look at my cross multiplication video, we'll be up to speed. So just take my word for it right now. So we have 300 times 1 divided by 6. And that's going to equal our x. Okay. Now let's go down here. Same thing. Okay. We're going to go in an x pattern again. Okay. It's cross multiplication. Cross like a crossing, railroad crossing sign, like an X. Okay, so 300 is across from 1 in an X pattern. That's our multiplication. So again, we have 300 times 1. Okay, we can use our dot there, or we can use our regular multiplication sign, or our asterisk like the calculator uses if we'd like. And again, we have 6 in an X pattern across from the variable, in this case X. That's what we're going to divide by. Okay. So we're going to divide by 6. Okay, so 300 times 1 divided by 6. Okay, so if you look, I told you whether we did miles over hours or hours over miles, we get the same answer. And exactly, because we have the same work. 300 times 1 divided by 6 equals x. So let's solve that out. So If we're using our calculator, we can just put that all in one line because it'll take care of the order of operations. Either way, though, we do have multiplication and division together. Order of operations would dictate that they would happen at the same time, just, you know, in left to right order. So either way, we'd still be good. So we do 300 times 1, which is just going to be 300, and then we're going to divide that by 6, which is going to leave us with 50. Okay, and our calculator confirms that. So 50 equals x, 50 equals x. Okay, so that was a heck of a lot of math, but let's take a look at what we saw. So how fast or how much, okay, miles per hour. Okay, so we saw how much, that's our variable. Okay, that's our x. So he went x miles per, that's our division, okay, hour, per 1 hour. So he went x miles per 1 hour, or 1 hour to go x miles, and he went 300 miles in 6 hours, or just like this, or it took him 6 hours to go 300 miles. And there we go. 300 times 1 divided by 6 equals x, 50 equals x. So if 50 equals x, x equals 50, how fast was he going in miles per hour? He was going 50 miles per hour. There we go. Pretty challenging problem, broken right on down, using our math talk keywords, and in this case, cross multiplication. Okay, now let's take a look at something else that we touched on towards the end of our call, and that was plugging things in and kind of the rules thereof. Now, let's get to a clean piece of scrap here. So when we say plugging things in, I mean anytime that you replace a variable with a number. Okay, so that could be in an equation or an expression. Okay, so let's look at an expression. Okay, so you know what? Yeah, I'll type it out again. I think it'll be easier for everybody to read. So here we go. So let's type out an expression. Okay. Simplify 3x for x equals 12. Okay. Now let's take a look at that one. Okay, so right now, what are our important parts that we're going to key in on? I see two numbers here. I see one number here, and then I see some variables. Okay, so I see x, I see 3x, I see 12. Okay, now what's that mean? Well, we're going to look at that in a second, but that's what I'm going to key in on first. So simplify 3x for x equals 12. So first of all, as an expression, we're just going to write 3x. But we know that x equals 12. So what that means is anywhere there's an x, there's going to be a 12, okay? But in order to solve this one, what we need to do is we need to plug that 12 in there. Now, how are we going to plug that 12 in there? Well, we could just take it and we could just put the 12 in, right? 3, 12. Well, that looks like 312 to me. 3 positive 12. Well, that's 3 plus 12. That's not working out either. We know there's multiplication happening in here, and that's important. Okay, so anytime a number touches a variable or number touches parentheses, there's multiplication happening. Okay, and that's important to know. Okay, so we got our multiplication sign, our time sign, our dot, our asterisk, like the calculator uses, whatever. Okay, so if a number is touching a variable or a number variable touching parentheses, we know there's multiplication happening here. So we could, just remember that and kind of throw our multiplication sign in, and that would work out. But let's look at a simpler way to do this, okay? So we write our 3x again, okay? And we take our 12, but this time, okay, we put our 12 in parentheses before we plug it in. Now let's see what happens now, okay? Now we have 3 parentheses 12. Well, 3 parentheses 12 means 3 times 12. 3 times 12 is 36. And we can check that right over on our calculator. 3 parentheses 12 equals 36. Perfect. So Simplify 3x for x equals 12. It's 36. Now, let's take a look at the calculator side of your screen for a minute, and we'll get a little bit deeper into why this parenthesis thing is so important. It's important because, yes, it preserves multiplication where there is multiplication, but it also preserves a negative number. Okay, so let's look at kind of how that works. So if you've gotten to exponents, like squares and things like that, great. If not, it's no big deal. If we say a number is squared, it just means it's multiplied times itself. So if we say negative 3 squared, okay, so negative 3 times negative 3, a negative times a negative is always a positive. So 3 times 3 is 9. So negative 3 times negative 3 should equal 9, which it does. So negative 3 squared, well, negative 3 times negative 3 is negative 3 squared, should equal 9, right? Negative 3 squared. Well, equals negative 9. How? Oh, order of operations. Check it out. So when we look at PEMDAS, or please excuse my dear Aunt Sally, parentheses, exponents, multiplication, division, addition, subtraction, we see exponents come long before addition, subtraction. So in this case, the exponent's happening first. 3 squared is happening, becoming 9. Then that negative, that minus sign is kind of going along with it and making it negative 9. So let's see how we fix that. We fix that by using parentheses. So parentheses negative 3 squared. What's that give us? That gives us 9. If negative 3 times negative 3 is 9, negative 3 squared should be 9. And it is if we use parentheses. So let's see how that works over here in one of our problems that we're working on. So let's go over here. Let's get a little text box going. Okay, so how much is one half of negative 18? That's a good problem. Okay, let's take a look at that. So, okay, how much is 1 half of negative 18? Well, we see two numbers, negative 18 and 1 half. Okay, so that's good. Focus on our two numbers. Now, when we look over here in our Math Talk keywords area, we can start figuring some things out. First is how much. What's how much mean? Well, it means variable. What do we like? X, Y, and well, we could pick another number if we want to. Pick P. Doesn't really matter. Okay, so here's P. So is, oh, that's a word. That's one we see a lot. Is means equals, right? Okay. Our numbers, well, our numbers are going to just come down the way they are. Okay. How much is 1 half of negative 18? Okay, so of is multiply. Okay, there we go. Okay, so P equals 1 half times negative 18. So 1 half times negative 18, negative 9. Perfect. Okay, so P equals negative 9. Now, if we want to check this problem, what are we going to do? Well, we're going to plug it back in, right? So if P equals negative 9, okay, negative 9 is going to equal 1 half times a negative 18. Okay, so we're going to plug that back in. Well, whenever we plug something in, we put it in parentheses, right? So we're going to take that negative 9, okay, put it in parentheses, okay, and we get parentheses negative 9 equals 1 half times negative 18. Sorry about that there. Hold on one sec. There we go. Okay. Now, let's take a look at a time where these parentheses will be a heck of a lot more important. Okay. Now, what if we have this? Instead of a word problem, what if we just wrote this? Let's look at some, let's look at a clean place to work here. Okay. Sorry about that, everybody. All right. This is probably good at places anyway right here. Okay, so now let's take a look at that. So if we have something like down here, let's use this as an example. Okay, so we have 1/2 times negative 18 equals negative 9. So let's go ahead and do that. Okay, so we're going to do 1/2 y equals negative 9. Okay, now what's going to happen here? Well, we're going to take a look at this. Okay, so 1/2 y. Well, what do we know goes in here? We know multiplication is going in here, right? So our dot, our multiplication sign, calculator would use an asterisk. Okay, 1/2 y equals negative 9. So to undo multiplication, we divide. Okay, so we're going to divide by 1/2. Okay, so 1/2 times divide by 1/2. That cancels each other out. But remember, our equal sign's like a little fence, okay? And it's like our neighbor, okay? And on either side of the fence, we have a really good relationship with our neighbor, and we share everything, okay? If they get 1/2, we get 1/2. If they take 1/2 away, we lose a half, okay? Here, they're getting divided by a half, we're getting divided by a half. So always the equal sign is like that little fence between you and your neighbor that share everything equally, okay? So there we go, divide by 1/2. Now, okay, so dividing by 1/2 cancels out this multiplying by 1/2. It just leaves us with y, which comes straight down, okay? So here we have y. Our equal sign comes straight down, right along down our little fence, okay? But now we have 9 divided by 1/2, okay? Now, negative 9, I'm sorry, divided by 1/2. So let's put that in the calculator, okay? And it's going to equal negative 18, just like it did in the other problem, okay? And we'll see when it's important to use these parentheses when we go to check it, okay? Negative 18, perfect, okay? So y equals negative 18. Great. Now let's take a look at our original problem. Our original problem was 1/2 y equals negative 9. Now if we want to check this, we're going to have to plug in our y value. Our negative 18 is going to have to get plugged in for y, and we need to put it in parentheses, okay? So let's do that, okay? So let's go over to our calculator, and we're going to put in this. We're going to put in 1/2 parentheses negative 18, and it should equal negative 9. And we're going to confirm that on our calculator. So here we go. First, let's try it without the parentheses, okay? So fraction 1/2 for 1/2, and we have a negative 18, we have minus 18, who knows what we have, right? So if we put in minus 18 by accident, I mean, if we put in negative 18, the calculator should know we're multiplying, but we might not know that on our own. But if we put in a minus sign, I mean, it's going to get all messed up. It's going to equal negative 35/2. I mean, that's crazy. So, all right, let's go back and let's make sure we use our parentheses and our negative sign. Okay, so hit our fraction button again. Okay, so we go 1/2, okay, and then we're going to use that parentheses sign, okay, and we're going to make sure we use our negative sign, okay, negative 18, there we go. So whether we're doing it by hand or we're doing it with a calculator, we're doing it the same way, and we're going to hit enter, and we're going to get negative 9. Perfect. All right, great job, everybody. That was quite a long video, but we did go through our PowerPoint, and we did a lot of algebra at the end, just like during our call today. So I hope that was helpful to everyone, and I'm looking forward to seeing you all back in class. Thanks a lot. Bye-bye.